Hi everyone, Mrs. Below here. In this video, I'm going to be going over the Chapter 8 notes, slides 1 through 4, specifically starting on slide 3, going over things that indicate if a chemical reaction has occurred and things that can affect the rate or speed of a chemical reaction. Because in this chapter, Chapter 8, we're talking about chemical reactions, things that can affect them, and then later in this chapter, predicting products of a chemical reaction. Remember, if you have a chemical reaction, so let's say we have something like this. So hydrogen and oxygen gas make water. This reaction would also have to be balanced, which now it is. The reactants are always on the left of the arrow. That's what you start with. That is what reacts. And the products are always on the right of the arrow. That is what you produce. And chemical reactions also have to be balanced to obey the law of conservation, because we can't create or destroy matter. Now, some things that can indicate if a chemical reaction has occurred is you could have light produced and heat energy. And a good example would be when we lit the magnesium on fire. That produces a very bright light, gives off a lot of heat. That can be an indicator of a chemical reaction. That would be what we call exothermic. So that's when you get that's when you get heat or light energy. You could also get endothermic reactions, which are actually cold. So there are some reactions where you do combine two things together, and the reaction will absorb surrounding heat. And if you take that heat away from those areas, then it will actually make whatever it is, like if the reaction's happening in a beaker, it will make it feel cold to the touch. Remember that what we're talking about here, these are examples of chemical properties because they're things that can only be observed by making some sort of a change to the chemical composition of that compound or element. Another indicator of a chemical reaction can be a gas being produced, such as bubbles. Usually that could be from like carbon dioxide, like when you combine baking soda and vinegar, that gas that's produced, that's actually carbon dioxide. You could also get other gases like hydrogen, which is really flammable, oxygen gas. You could get other gases that could be produced, but those are the most common that would result in bubbles. Next, you can get what's called a precipitate. And that happens when you combine two liquids together and you get a solid. And the last is a color change, could also indicate a chemical reaction. Again, these are all types of chemical properties or chemical changes. Remember, physical properties or physical changes, that means that you're not changing the identity of that substance. It could be a phase change like melting, boiling, freezing, etc. These are all chemical changes or reactions or properties. There are certain things that can affect the rate of a chemical reaction, so how fast or slow it will occur. The first is actually biology related. It's called a catalyst. A catalyst is something like an enzyme. So enzymes are really good examples. Enzymes are actually proteins, and they're in our bodies, and they help actually to speed up chemical reactions in our bodies, which is really important. Otherwise, like, those reactions wouldn't happen very fast naturally on their own. And oh, I'm sorry, that's this blank is catalyst. Okay, we'll get back to this one in a second. So catalyst is something like an enzyme, and it's going to speed up a chemical reaction by lowering the activation energy. So here's an example over here. So this is how much energy would be required for that reaction to occur like naturally on its own. But with an enzyme, you lower the amount of energy needed to kind of like kickstart the reaction. So it will occur faster then. And those are more biological related. Those are things that are really important in our bodies. Probably one of the most obvious ones is temperature. If you increase the temperature, that will make the atoms or molecules move faster, and then they can interact with each other faster and thus react faster. That's related to kinetic molecular theory. If you increase the temperature, you're adding more heat energy, so those molecules or atoms will have more kinetic energy, so they would move faster, interacting with each other faster, and thus reacting faster. And the last one is particle size. So if the particles are smaller, they're going to have more surface area, so then they have more of a chance to react. So for example, if you have like an Alka-Seltzer tablet, normally you drop it in water, it fizzes, and then it will eventually react and it will dissolve in that water. But something like this, if you drop it in, that has a lot less surface area than something like this. If you were to crush up that tablet into a powder form, then it will have more chance to interact with the water because it has more surface area and you broke up those particles, and that will make the reaction go a lot faster than if it was that solid tablet. And those are a few things that can indicate if a chemical reaction has occurred and things that can affect how fast a chemical reaction happens. Remember, reactants are always on the left of a chemical equation. Products are always on the right. And chemical equations always have to be balanced in order to obey the law of conservation, which is matter and energy cannot be created or destroyed.